Hello my dear children, how are you all? Welcome back to the channel. Today I'm here with your completion of the chapter application of derivative. Okay, so we have done the chapter in three parts, part 1, part 2, part 3. We discussed every topic in detail one by one, whether it was maxima, minima, increasing, decreasing function or rate of change. All these topics are very important because questions can be asked on, one question can be asked on from each of the topics. Okay, so today I'm starting with the last session of the chapter, which is going to be PYQs of the chapter AOD. Very much clear what we are doing today. Okay, so without wasting time, let's start the session. First, of course, let's discuss what's going to come for the session today. So we have top 12 PYQs that I've taken, which includes your 2025 PYQs as well. We're going to solve in detail. When I say top, means these are the questions that can be asked. Okay, means the varieties, if you see these problems, can be repeated. The pattern can be kept same, and the questions style can be changed. You'll see that the similar question can be expected this year as well. So starting with the question number 1, as I said, total of 12 questions, top 12 questions from the PYQs, not all, top 12. We'll see question by question, starting from the number 1. Now this problem does not require derivative, because check here the function given to you, y equal to 3 plus mod x. Looking at mod, we all know it's never differentiable because it has a corner point in it, right? In the domain they have a corner point, a sharp corner. Of course, non-differentiable. Please check. Local minimum they're asking us to find, but good thing for us is we don't need that as well. If I'm looking for mod x curve, we know that this is going to be from here, but we are adding 3 to that, means the curve will go to this point. This will be your value 3. Please check. Mod, this is the curve for 3 plus mod x. Now for this curve, of course, the minimum value can be defined over here, and the maxima is of course not defined, right? Where will you find the maxima? There's no point. If you keep going towards the right of x-axis, towards the right of y-axis, you'll keep getting the maximum values every time, right? So you cannot define any one fixed maxima, but you can define a minima. So this will become your local minimum value for the given function. Answer is going to be what? 3. See, so we can get a question from AOD without actually application of the derivative, because the function is non-differentiable at x equals to 0. Non-differentiable. Simple. Question number 2 now. One was fun. Now these questions will have some of course applications of derivative, right? Please check. A stone is dropped into a quiet lake and waves move in circles. Okay, waves are moving. What is the meaning of this? Wave moves basically is the radius is moving, right? This is the radius R1, R2 and R3. Radius is moving from R1, R2 and R3. Basically the speed of the wave is nothing but change in the radius. So speed is nothing but dr by, please check here, dr by dt. We can write this value 5 centimeter per second as dr by dt. I hope all of you know this, right? That's why we can get the data from here. At that instant, when the radius of a circular wave is 8 centimeter, they are defining that also. Means they are giving you an instant when the outer radius of a wave is basically 8 centimeter. Means the radius value is also given as 8 centimeters. How fast is the enclosed area increasing? What are they asking now? They are asking you rate of change. Fast means rate of change of what? Area. As simple as that. Let's calculate it. Area of a circle will be given by pi r square. Okay, pi r square. Now if you go from here, I'm looking for dA by dt, right? I'm looking for dA by dt. I have to write here. Please check. I have to write here pi 2r. Is it over? No. We must write here dr by dt. Dr by dt. Because derivative is with respect to the variable t, not r. If it was with respect to the variable r, we'll simply not write this part. Okay, but since the variable where we are differentiating it is the t, we got to write dr by dt. Okay, now we have the values. Please check. We have pi, we have 2, r is given as 8 and this is given as 5. 8 5s are 40, 40 into 2 is 80. Option number D is correct. Got it? Option number D is correct. Question number 2 is clear. Have a look. Question number 3 now. 2 is clear, sir. Simple question. Third one. A balloon which always remains spherical. Okay, good for us. Volume will be for a sphere 4 by 3 pi r cube. If it is a volume question, we'll see. Inflated by a pumping. Okay, they're saying that right now balloon size is this. I cannot draw the balloon properly, so maybe something like this. Okay, so you'll have a 3D shape, of course. It's increasing, so you'll go to this. So volume is of the balloon is from here, here, it's increasing. Okay, please check. When you pump in the air to a balloon, what happens? Size is here, then goes increasing like this, correct? Please check. That rate of pumping the air is what? 10 cubic centimeters of gas per second. Basically, you are increasing the volume. The rate of change of volume is actually given to you. What is given to you? dV by dt is given. Rate of change of volume is given to us, and that is how much? 10 cubic centimeter means centimeter cube per second. No problem over here. It's very important to write the data given to you. Extremely important, right? Okay. Find the rate at which the radius of the balloon is increasing. What are they asking? They're asking us dr by dt is how much? When the expansion is there, right? Of course, radius is increasing every time. So they're asking you that value, and of course, that instant is given as 15 centimeter. What's the meaning of this? If there's expansion, right, there will come an instance when the radius becomes 15 centimeter. If you keep filling in the air or gas in the balloon, it will keep expanding, and there will come an instant when the radius will become what? 15 centimeter. So they're asking you at that instant, what is the rate of change of radius? Got it? Okay. Let's find the V first. So V is nothing but 4 by 3 pi r cube. That's the volume of a sphere. Let's differentiate it. We're going to write here dV by dt because we have the variable given as dt over here. We'll have this 4 by 3 as a constant. This will become 3 pi r square, and of course we have to write dr by dt over here. All of you agree? Because the variable is t. 3 and 3 gets cancelled. We can move all of this over here. This value is 10, right? This value is 10 divided by 4 pi r square equals to dr by dt. Since we were supposed to find dr by dt, right? We were supposed to find dr by dt. That's why I've kept this over here and rest all on that side. What is left here? 4 pi r square. Okay, let's see the calculation now. So what I'm getting, dr by dt equals to 10 is there in the numerator, denominator 4 times of pi of course is there, and r square. R is given as 15. Square of that is how much? 225 right here. 225. 225 into 4. 200 into 4 is what? 800. Right? 200 into 4 is 800, and 25 into 4 is 100. It becomes 900 actually. So I'm getting here 10 upon 900 pi. 0 0 cancels. Answer is 1 upon 90 pi. 1 upon 90 pi. That's my answer. Please cross check, guys. Option C is correct. Okay, option C is correct for this one. Yeah. So B, D, C so far. 3 is clear. Please have a look. Question number 3 is simple, right? Just understand what they've given. Once you crack the given statements over here, next step is to simplify the formula that we have and differentiate that with what the variable given to you, and you can get the result from there. Next is question number 4. If x is real, then maximum value of this is what? Now, I have taught you this already. You can use both the approaches over here. You can use derivative approach. You can use the simply parabola approach also. Check this out. Parabola, upward parabola, right? X square minus 8x plus 17. What are they asking? Minimum value. Can you find maxima for this? You cannot. It's a upward parabola, concave up. What happens there? There is no maxima. There is only one point of minima, which is going to be at vertex. Going to be at vertex. And how do you find vertex coordinate? Minus b by 2a and the function value at minus b by 2a. Correct? That's how you find the coordinates. Okay, so your choice. You can do this. Minus b by 2a means minus of minus 8 upon 2 by 2 into 1, right? So it becomes what? It becomes 8 by 2, which is 4. And you want the function value. So f of 4, please check, will be what? 16 minus 32 plus 17. How much is that? Add these two. We get 33 minus 32. Answer is coming as 1. Option C is correct. This is method number 1. Method number 1, where we don't use derivative, simply use the formula of the vertex. We have learned that in PU1. Remember, vertex is going to be minus b by 2a, and the y coordinate is going to be f of minus b by 2a. Find the minus b by 2a value. This is what? This is minus b by to a value coming as 4, put the 4 in the function to get the minima value as 1. Otherwise, we have another approach. F dash of x you're going to find. You'll have this as 2x minus 8. Put here from 0. What do you get? X equals to 4. You have only one critical point anyway, so don't have to find this other thing. Simply find f double dash of x if you want to check. You'll have what? You'll have here simply 2, which is less than 0. So it means, sorry, not less than 0, more than 0. So it means what? It's going to be point of minima. Okay, so I get f of 4, and again it will come as simply 1. So you can have the method number 2 or 1, your choice. You can have method number 2 or 1, your choice. Alright? Okay, this is clear. Clear, fourth is clear. Alright. Answer is option number C. Question number 5 now. Question number 5 now. The rate of change of area of a circle with respect to its radius. Okay. So area, right? They're asking you dA by dr. They're asking you dA by dr. How do you find this? Differentiate pi r square. You get 2 pi r actually. You'll get 2 pi r, and they're saying that radius is 2 centimeters. Right here, 2 into pi into 2, you'll have 4 pi. Answer is option D. Please check. Yes, so question like this also comes. That's why I'm saying NCERT is very important. This is NCERT question, right? Very simple, straightforward formula putting answer. Very, very simple. Okay, 5 is clear. Question number 6 now. Excuse me, got a little cold I think. Okay, question number 6. Function fx equals to x square plus 2x minus 5 is strictly increasing decreasing function question. Okay, how do you solve this? Step number 1 is to find derivative. Step number 2 is to plot the number line. Sorry, step number 2 is to find the critical point, and step number 3 is to plot the number line. Let's do that. First step, f dash of x. What do you have from here? Please check. 2x plus 2. Put this equal to 0. The second step, f dash of x, which is 2x plus 2 equal to 0. I get x value as minus 1. X value as minus 1. Next is what? The number line. Step number 3, the number line. Minus 1 over here. Rest, this is plus infinity. This is minus infinity. Okay. I'm looking for, please check the coefficient of x. I'm looking for increasing function. Okay. I'm looking for a strictly increasing function. Please check for coefficient of x is 2. Positive number. So put plus sign on the right side. Over here minus sign. Plus represents what? That f dash of x is more than 0. This represents f dash of x is less than 0. Negative represents less than and more than. What I'm looking for? I'm looking for strictly increasing. It means that I'm looking for f dash of x more than 0. So my interval, please check. Minus 1 to infinity. It'll be both open. It'll be both open because we're talking about strictly increasing. If it was just increasing, we can keep this as close bracket also. If this word was missing from here, we did not have strictly word over here, only increasing, then answer will become D. Answer will become D. But in this case, they have mentioned what? Strictly increasing, we got to go with the option A. Option A, which is minus 1 to infinity. I hope you can see the difference. Just the word strictly makes the change, either 1 or D. D, when there is no strictly word written over here, there will be no equality over here. There will be no equality over here. Okay? Clear? 6 is done. Question number 7 now. The rate of change of volume of a sphere with respect to its surface area is going to be what? They are asking you dV by ds. What is this? This is the parametric form that you have learnt. Please check. dV by dr divided by ds by dr. Right? Have a look. What I get? dV by dr. Differentiation of 4 pi. 4 by 3 pi r cube is what? Is my v. So my dV by dr will become what? It will become 4 pi r square. All of you know this. Because if you take the 3 over here, 3 will cancel the 3. It will become 4 pi r square. Same fashion, if you take S as, what's the surface area of a sphere? Simply 4 pi r square. Okay. Differentiate this ds by dr. You will have this as 8 pi r. Now use the values that you got over here in this. You get 4 pi r square divided by 8 pi r. 4 pi times 2 is r square, so is 2 is 8 pi, and r cancels. You have answer as r by 2. You have answer as r by 2. What's the value of r? 4. Put here. You get this as 4 by 2, which is nothing but 2. This is going to be a value for rate of change in volume with respect to the surface area. So it will become 2 centimeter cube upon centimeter square. That's your answer. Option A is correct. Please cross check. Option number A is correct. Clear? 7th is clear. Okay. Let's move on to question number 8 now. So if you have any doubt in any of the question that I have done so far, you have to let me know in the comment section. Okay. Let's say question number 7 or whatever it is. They're not very difficult, but still, if you have any, you can ask me. Do not hesitate, guys. Bacha, anything that you want to feel. Whenever I come in live, you guys keep asking me questions. Right? You ask me, sir, I'm not getting this, I'm not getting that. You ask me questions in the live sessions, but not in the recorded. Why? Who's stopping you? So don't forget to give me your queries. I'll answer them. Okay? You're having difficulty in this question, you let me know. What's the problem? It's okay, you can type it. I'll get back to you. I'll tell you what is going wrong. How can you change that? I can take a live session and just talk about that. So do not worry. Please let me know what is your concern and we'll focus on that. We'll work on that. Okay? Question number 8 now. Time to solve this. The maximum value of 1 by x to x. What type of question is this? Check here. Power. Log application. Okay? Check the function as y equal to 1 by x to power x. This should click to you. When you look at a question like this, you should click to you in the mind that, okay, fine, this is from that category of differentiation. Okay, great. From here, differentiate now. So you get, apply log on both sides first, right? So you get log y equals to log of 1 by x to power x. Okay, can be written as log of x power minus x. Correct, na? I can write this 1 by x as x power minus 1. So it will become minus x and simply take this as coefficient. So what I get? I get log y equals to minus x log x. Minus x log x. What is the next step? Differentiate. Okay. So you'll get here 1 by y and you'll get y1, which is the derivative of y. Okay. And this will become what? I have to use the product rule over here. Keep the minus sign outside. And over here what I'll get? I'll get this x as simply 1. So 1 times of log x. Plus sign will come. X as it is times of 1 by x. Derivative of log is 1 by x. This x and this x cancels. Okay. What I'm getting now? I'll write this y1 here and move this y on this side. Okay. So I get y will be minus y times of 1 plus log x. Right? 1 plus log x. What is the next step to find maximum minima? Is to put it equal to 0 to find the critical points. So put it equal to 0. What is the y value? Y is 1 by x power x. It's exponential part. It will never be 0. Okay? It will be a non-zero value. This y can never be 0. Can never be 0. Never. Okay? So it means this bracket has to become 0. To make this whole expression 0, this bracket has to become 0. Can happen only when 1 plus log x is equal to 0. Please check. Log x is equal to 1, sorry, minus 1. Now apply e on both sides. So apply e over here and e over here. What do you get? You get simply x left on this side and it will become e power minus 1. Hence, the value of x is what? 1 by e. 1 by e. So you get the critical point as only one critical point where it is equal to 1 by e. So you have the critical point now. First step was to do the derivation. Second step was to put it equal to 0 to get the critical point. The third step is to simply put back in the function. Actually, we're supposed to find the second derivative, but we don't have to because we have only one critical point. If we had more than one critical point, no. If we had, let's say, another point over here, then we have to do another time. Okay, and we had an option over here like none of these. Think, if we had one of the option as none of these, okay, and we were having two values over here. Then we'll have to do the second derivative also to cross check whether this point is a point of maxima or minima. But since we have none of the case, we have only one critical point and there's no option over here given as none of these. I don't have to find second derivative. We don't have to waste the time on that. Simply find, put the value back in the function. So what is the function given to you? Y equal to 1 by x power x. X is 1 by e. So 1 by x will become simply e. And what is x value? 1 by e. So your answer is e power 1 by e. See. Please cross check. It's a good question. Not difficult, of course, but it's a good question. Please have a look. Clear all of this to all of you. Okay, question number 8. Had fun? Now question number 9. Similar problem. What are they asking in this case? Stationary point. Basically, point of extremas. Whether it is maxima or minima, we don't have to worry about that. Simply they're asking you critical point. This word means here critical point, point of extrema, point of minima, maxima, doesn't matter. It's the same thing. We're looking for only critical point. So we'll have to do the first step, finding derivative, and second step, putting it equal to 0 to get the critical point, and that's it. No need to check the second derivative. No one have to do all of that. Okay. Step, start with the function. So same thing, y equals to, we have x power x. Apply log on both sides, we get log y equals to x log x. Remember, this x comes in front. Derivative will make it 1 by y, y1, and over here we'll have what? X into derivative of log will be what? 1 by x plus, this time we'll keep derivative of x. So it'll become 1 and log x as it is. Log x as it is. So I'm getting this x and x cancelled. Now y1, which is the derivative, which is becoming equal to, please check, this y goes over here, it comes y times of 1 plus log x. That's my derivative. That's my step number 1. Step number 2, put it equal to 0. y1 equal to 0 you put, so we get y times of 1 plus log x equal to 0. I told you already, y can never be 0. It's exponential function, never be 0. Okay. Then what happens here? Please check. Of course, this part has to become 0. So I get 1 plus log x equal to 0. From here I'm getting same thing that we did in the previous question. Minus 1, apply e on both sides, we get simply e power log x, and here e power minus 1. Okay, so my answer will become what? Is one step. Okay. 1 second, guys. I'm taking e on both sides. Okay. E over here, e over there. It becomes simply x, because e and log are inverse functions. So it becomes simply x, and over here we'll have what? We'll have 1 by e. E power minus 1 is 1 by e. Answer will be B, right? Answer will be B. Question number 9 is also over. Please check. Question number 9 is also done. Download these class notes in the PDF format. You have to join the WhatsApp channel if you have not joined yet. If you have joined, you'll get the PDFs there. So please download and cross-check and solve all the problems again. Simple means actually you have to solve it for sure. Reason very simple, because if they are simple questions, if they come in the examination, you can save some time solving it. So you have to have a very good practice in the simpler problems. Okay, because almost 25 to 30 questions will be easier questions. So you got to give them very much preference. Moving on to question number 10 now. Now we have maximum area of rectangle inscribed in a circle. So over here, dear, we have to remember one statement. The largest rectangle, if you are watching this video, repeat after me. The largest rectangle that can be inscribed in a circle will be a square. The largest rectangle which can be inscribed in a circle is there. I'm looking to inscribe a largest rectangle. This will actually be a square with diagonal on the diameter of the circle. Of course, that has to be the case because this corner is 90 degree, right? We have learned in grade 10, if this is 90 degree means this has to be the diameter. That's not a problem. Okay. So what my question was, if you are looking for a largest rectangle, that has to become what? That has to become a circle. That has to become a square actually. And the area of that will be what? This will actually become root 2r. Side will be root 2r. Root 2r, I guess. Yeah. Okay. So area will become what? Simply 2 root 2r into square. So we'll get what? 2r square. 2 times of square of r. Check from here. Standard form. X minus of minus 1 the whole square plus y minus of 3 the whole square equals to 8 square equals to 8 square. Excuse me. Equals to 8 square. Okay, so I get the radius from here as 8. This is the standard form of circle. This is the standard form of the circle, x minus h, y minus k squares, and this is r square. So radius is 8. Put here 8 square. Answer will become what? 2 times of 64. How much is that? 128. Option B is correct. Option B is correct. Now, if you want to ask me, sir, is there an approach to solve this question using AOD? Is there, but it will take too much time. You have to, represent the, you take the length and breadth as L and B or X and Y. Then you have to go ahead and, write one of the variable in terms of the other variable. Okay, it will be too much time. And then differentiate the function of the area, correct? So, you don't have to do all of that. No need to do any of this, okay? Simply remember, the largest rectangle that is inscribed in the circle is always a square, and in that case, check this out. What does this become? This will become 8 and 8, right? Basically R and R. So you'll get this value as what? Square of this value, and this value should be what? If this is a value and this is a value, please check. You will have a square plus a square equals to this. What is this? Diameter 2r square. What I'm getting here? I'm getting this value as, please check, 2a square equals to, what is this? 4r square. So this gets cancelled. I'm getting the a square value equals to what? R square. Cross check. Cross check. What does a square represents? Is the area of the square over here. And what is the, 2r square. That's what I used, right? That's what I used over here. Please check. Okay. So you don't have to do all of this. Just remember 2 points in a question like this. Maximum rectangle's area, largest rectangle in a circle will be a square, and area is given by 2r square, because side becomes root 2r. Side becomes root 2r, hence the area is 2r square. This is just to explain you how it is working out, but it's just simply steps are here. The steps are simply here. Clear? Answer is option number, I've written as option B, right? There's a mistake, guys. This is option number C, right? Okay, this is option number C. That's option number C, okay? I wrote this as B and B. This is option number C. Please check. A, B, C, D, right? So this is 128. Option number C is correct. 10th is over. Question number 10 is done. Question number 11 now. The minimum value of 1 minus sin x. Again, this is a question which does not require derivative. And this is from which year? This current year. So basically, there can be a question which do not require, your application of derivatives. In the question from AOD, I can show you over here. Please check. 1 minus sin x will not differentiate at all. Just tell me the range of sin x. It is either minus 1 or plus 1. Minus 1 to plus 1. That's my range of sin x. Okay. I'm looking for minimum value of this function. That can happen only if the sin x is 1. Because if you take the extreme value of minus 1, it will become 1 minus 1. If you take 1 minus of minus 1, it will become simply 2. But if you take 1 minus of the positive value, the largest value of this, it will become 0. Can you get anything other than this? So basically, for the function y, this is your y max and this is your y min. This is your y min. Tell me, can you get a value lower than 0? Can you get a value more than 2? No, because sin x has a limitation of minus 1 to 1. In that case, your y minimum is nothing but 0. Answer is 1. Option A. Please check. Option A. I'll write this as A only. So 0 is the correct answer. This is the minimum value, 0. Got it? Clearer? Okay. Next question. Number 12. The function fx equals to tan x minus x. Function fx equals to tan x minus x. How do we solve this question? Okay. Same thing, you have to do the derivative. You get here tan x as sec square x. Okay. And minus 1. What are they asking us? We have to check the nature, increases, decreases, and all those things. We'll see. So right now we have the derivative. To check for increasing function, we need to know the derivative is either more than 0 or less than 0. Correct? Or we have to know the trend, right? Basically, we have to know the sign of the derivative. How to do that? Simply substitute sec square value as this formula. 1 plus tan square x as sec square x. Remember? this formula. If you do that, please check what is going to be 1 plus tan square x minus 1. I'm writing x square as 1 plus tan square x. 1 and 1 cancels. Now check this out. F dash of x is becoming what? Simply tan square x. Square of some value. Square of some value. It'll be always positive, right? It'll be always positive. It'll be always positive. It can be 0 also, but always positive or 0. Basically, I'm getting my derivative of x is more than 0. Answer will be always increases. Option A is correct. Question number 12 is also done. What is the answer? Always increases because derivative is coming as positive. Answer option A is the right one. You can see the questions are very simple from this chapter AOD. So you have to make sure that you get both the marks. 2 or 3 marks comes from here. So you have to make sure that after doing continuity and differentiability chapter, you've studied that, right? If you studied, you put a lot of efforts in the chapter C and D. So you got to get these 2 marks also. It's a bonus. These questions are bonus for you. So you have to make sure that you're getting these 2 marks. You have to promise me that right now. AOD, you will get 2 marks for sure without any mistakes. Okay, I have made sure that. And if you have any other thing to tell me, if you want something else also from this chapter, you got to tell me in the comment section. We'll see what we can do about that. But that is it for today. We have completed our chapter application of derivative. We had fun. I had fun teaching you. I hope you had fun learning from me. Anything else you want to add to the session, let me know in the comment section. That is it for today. I'll see you again very soon. Till then, take care of yourself. Bye-bye.